What if you wanted to know the answer to a simple question, like what is the biggest US state? Well, you could go to a traditional search engine like Google or DuckDuckGo and you could look it up here. So what's the biggest US state? And you'll get a bunch of results. And looks like by this, the biggest one is Alaska. But now you could use things like large language models so that it can just spit out an answer for you and it's just in plain text, so you don't really have to click on any links or go through anything to find your answer. So I could look it up right here, and after a little bit, it'll spit out what I assume is Alaska. Yep. So same answer as DuckDuckGo, and it's got a little bit more information. But here's the thing. By using Copilot and OpenAI's ChatGPT or even Google's new Gemini or whatever they decide to call it, you have to abide by their terms of use and you have to look at their privacy statement to see what they're actually doing. Microsoft collects data from you through your interaction with you and through our products. By using ChatGPT and Copilot and stuff, you're basically saying, yes, take my data, use it. But what if you don't want to do that? What if there was a way where you could run a large language model locally, quickly, and get an answer to your simple question? So in this video, we're going to be creating a command line application using Rust so that you can just simply open up the terminal and type, hey, what's the biggest US state? And it'll just spit out an answer for you much faster than any of the other results. Then if you want to follow up, so let's say, hey, what about the second? It's still able to read context and give you an appropriate answer. So let's see how to do that. You're going to need to have Ollama installed locally as well as a model of your choice, but we're also going to make a setup script so that when you decide to publish this, anybody who wants to use this doesn't have to have Ollama installed right away. We'll create a setup script to take care of all of this so that it's super easy for the end user to use your command line application. I'm going to be making this for Linux systems, so things will be slightly different for Mac and Windows in terms of the commands and the bash scripts, but with a little bit of work, you can adapt it to your operating system of choice. In my previous videos, I've written out the code line by line and walked through it, and I'm just going to walk through it this time rather than writing it out line by line. I'm still going to try my best to explain everything and make it as clear as possible so that you can still follow along on your own. Like I mentioned earlier, we're going to be using a programming language called Rust. And Rust is a low-level language, so it's pretty akin to C. It's a bit more complicated than if you only have experience with Python or JavaScript or things like that. Rust deals with things like pointers, memory addresses, and just low-level stuff that you wouldn't really have to deal with in Python. But it's still a pretty good way to learn coding, especially at the lower level. I haven't used a low-level language since I was in school and learning C. So this was my first Rust project, and it was definitely tricky just dealing with all the build and compiling issues. But it's definitely worth it to learn it in the long run, because with Rust, you can create applications that are super lightweight and super efficient, and you can really make it optimized if you know what you're doing. So starting off, just make sure you have Rust and Cargo installed. You could just look up how to install Rust, and it should be a simple one-line command. And once you do that, you're going to be able to run Cargo, which is Rust's package manager, and you can just set up a Hello World application. So you can do something like Cargo, new Hello Cargo. So I'm calling this Hey LLM, and what I did to start this off was I ran Cargo new Hey LLM, and it basically created a Hello World application for me. We've got the main file over here, we've got the Cargo dependencies list, we've got the package lock, and I added a README. I added this setup sh, which I'll talk about later, this executable, which I'll also talk about later, and just a git ignore. The first thing we have to do is set up our dependencies. So in this case, we're going to be using a package called Tokyo, specifically version 1 with the features macros and RT multithread. We're going to be using Ollama RS. It's basically a package that lets you make requests to your local Ollama instance. And then we're going to be using bin code so that we can serialize and deserialize and save our chat contexts. At the top over here, we've got our import statements. So from the Ollama RS package, we're going to be importing generation completion and specifically the generation request types, generation context types, as well as the Ollama client. From the standard package, we're going to be importing IO, path, FS to read files, and env so that we can see command line arguments. And then we have bin code over here. So in Rust, you actually can't make the main function asynchronous without doing a little bit of work, but luckily the Tokyo package takes care of it for us. So we're just going to be declaring it right up here so that we can make our main asynchronous. Otherwise, if we didn't have this line over here, when we tried to build the package, it would throw an error saying main can't be async. But under the hood, the package does stuff that allows us to keep it asynchronous. And the reason we want it to be asynchronous is because we're going to be sending a network request to our local host so that we can get information from our local Ollama instance. Starting off, we need to extract the command line arguments. We're going to be using args.collect from the standard package. We're going to be assigning the command line arguments to be a vector of strings in the args variable. Now let's actually break out the arguments and assign them to their own variables to make it more clear what's going on. You'll notice that we're starting args with index 1, and that's because index 0 is the name of the file and the function that's being run, so that's technically the first command line argument, and everything else after, the optional ones, are what we're interested in. So if I did something like cargo run -- llama 2 uncensored, this is the model that I want to use in Ollama, and this is the first command line argument. But it's still stored in index 1 because index 0 contains the rest of the run information. Our first command line argument, llama2 uncensored, is going to be assigned to model. And we have an ampersand here, which means model should be assigned to the address of args1. And that sounds a little weird if you're coming from Python, JavaScript, Java, or anything else, because it is. In Rust, you can't copy over a string. What you can do is copy over the location in memory where that string is stored and assign it to a variable. So basically what this is saying is assign model to be the location in memory where args1 is, which if we know what args1 is from here, it's llama2 uncensored, and this is the string that is stored in the piece of memory that we're declaring to model. Next, we need a prompt, so something that the user wants. This would be something like, what's the biggest US state? And this would be assigned to prompt, and the same principle applies to assigning strings versus assigning memory locations. And now we have this thing reply, and this is going to be an optional parameter, and we're going to check to see if args length is 4. And the reason it's 4 is because, like I said, you can think of the stuff before llama2 uncensored as index 0. So this is the first argument, the second argument, the third argument. And now we want to see if a user did something like put a -r flag to indicate that it's a reply to something. If it is, we're going to assign reply to -r, and we're going to move prompt over just one index. So prompt is actually going to be what's the biggest US state. But if it's not a reply and it's a fresh query, we're just going to ignore it and we're going to keep prompt as index number 2. And just to make it more clear, when we have the finished product and we do something like, hey, what's the biggest US state? This is the fresh start query. This is something that we don't need any context to answer. But if a user wants a follow-up, that's when we use -r and give it a second prompt. And that's what we're basically checking for here. Is it a reply or is it not? And you'll see why that's important in just a sec. So now that we got the arguments, we're going to create a mutable request variable. And for that, we're going to do generation request new. It expects 2 parameters, a model and a prompt, and they need to be strings. So we're going to take the address of args1 that we have that we're storing as model, and we're just going to expand that out to be a string. So rather than returning a space in memory, model2string actually returns the underlying string, so llama2 uncensored, which is the underlying string stored in args1 that we're getting the address for. And we do the same thing for prompt. We're going to skip over to this part just for now, the building context part, and we're just going to go through the bottom and then circle back to this. We need to initialize an Ollama client, so to do that we're going to use Ollama default and assign it to be in the Ollama variable. And then we're going to call the generate function in Ollama in the client with our request object that we created. We're going to await it, and we're going to assign the response to be in res. And over here, this is a bit of pattern matching. If the res that we got back here matches okay res, which means that it's okay, it means it returned a 200 status code, which means it was successful. If it matches, then we're going to move on to the rest of this if statement. So basically, if I call this like res2, this was res2, it would still work the same in the underlying function because we're basically making sure that res2 returned an okay, and then we're going to move on using the block scoped variable res. So if I wanted to call this res a, that means everything that uses res in here would need to be changed to res a because it's in reference to res2. It's a little bit confusing because I'm using the same name, but basically just think about it like this. We're making sure that res is okay. If so, whatever is in the okay right here is going to be the variable name that we use for the rest of it. So at this point, when it passes this line, the Ollama generate function returned a success response. And so we want to print the response. So to do that, we look at res.response and we use a little bit of string formatting here because Rust doesn't allow you to directly print res.response. You need to use string formatting. And at this point, this is where the large language model would have responded with the biggest US state is Alaska, and that would just be printed onto the console. And now we have some more pattern matching. So we want to see if res.finalData exists. If there is some value res.finalData, assign it to final data. If there's none, it just won't do this. But if there is final data, we're going to go into new context, and we're going to use the sum option over here. So the option enum, basically there's some and there's none. So if there's no value, it's none. And if there's some value, it's some. And it's a good way to check just to see if a value exists. And that's because Rust is super strict with its typing. So rather than seeing if final data context exists, we actually assign it to be, okay, there is some value for final data.context. Assign it to new context. The reason we do this as opposed to just assigning it to be final data context is because later when we add context to the request, the Ollama RS package is actually expecting it to be a option enum, so it has to be some or none, and we're just setting that right now. Then we're going to encode new context, and the reason we want to encode it into bytes is because we want to save it to a temporary file so that we can use the context later on. And I know it feels like everything is kind of all over the place right now, but I'll do a second run through after I'm done explaining all the lines, and hopefully that'll make it more clear. So we're going to use bin code serialize, and we're going to serialize the new context struct. So final data.context is going to be in the form of generation context. We just want to turn it into bytes so that it can actually be stored into a file. We're going to turn it into a bunch of 8-bit unsigned integers. So once we have the vector of bytes, we're going to save it to encoded. And then we're going to create a variable f, which is going to be a file that we create. We're going to call it hey context, and we're going to store it in the temp folder. You can choose wherever you want to store it. I chose to store it in the temp folder because it's good practice, and it's just a temporary file. It's not important in the long run to preserve over time, and if it gets deleted, it won't be the end of the world. And then if it fails, we're just going to throw an error unable to create file. And then once we've created it, we have to actually write into the file. So we're going to use write all so that anything that's already been written in there just gets erased. And then we're going to write into it with encoded. And the same thing as before, if we run into an exception, we're just going to give it an error message saying unable to write data, and it'll pass it in more context. So now we sort of have the full picture minus context. So I'm just going to step through that real quick. So let's just ignore that for now. We're getting the command line arguments, and we're getting where they're stored in the underlying memory and assigning it to model, prompt, and optionally reply. We then create a request object and get the underlying string for model and prompt, and create a request using the specified model, so Llama 2 uncensored, and then the prompt, what's the biggest US state. We're initializing the Ollama client from the Ollama RS package we're using. And we're going to call Ollama generate request, and we're going to await it so that we can get a response stored under res. We're going to do pattern matching to make sure that res returned an okay at 200. If so, we're going to print the response. And then we're going to look to see if res.finalData exists. If it does exist, then we're going to create a variable new context, and we're going to save it as some final data context. And the reason we save it as some final data context as opposed to just final data context is it's going to be used like that later as an option enum. So I'm just going to keep it there for simplicity's sake. Once we get the new context, we're going to encode the message, and then we're going to save it to the temporary file hey context. And then we're going to write the encoded message into hey context so that it could be used later. But at this point, if a user just asked, what's the biggest US state, it would return a response because we don't care about context right now. It's just a straightforward question that requires a response and no other background messages. So at this point, if we did cargo run llama 2 uncensored, what's the biggest US state, it should work. But the problem is, what if a user wants to follow up on the last sent message? That's why we saved the context so that we could then use it later. Now I'm going to uncomment this stuff out. And let's just talk through it. So a valid reply would be -r. If we wanted a follow-up for it, for whatever the last message was, we would just do -r. And now we know, okay, we need to use the context that we saved to the temp file. So now we check if reply is equal to a valid reply, the address of the string and the string can be directly compared and it works out. So if reply matches valid reply and it's -r, that means we know that the user wants to reply to the last message that the LLM sent. So we also have to make sure that there is actually context that we've saved from a previous session. We're going to be using path, new, and we're going to be seeing if the hey context file exists in our temp directory. And this part right here would match wherever we created the file. So if you placed it somewhere else, then these two lines should match. If it does exist, then what we're going to do is we're going to read the hey context temp file and we're going to store it in data. Then, because we stored the data as a vector of unsigned integers, as basically bytes, we want to decode the bytes so that it can actually turn into that struct that we can actually use in our function. So we're going to call bin code and we're going to deserialize our data and unwrap it. And because it is a vector of bytes, we just want to get all of the entries. So if we just did like index 0 or something, we would get an impartial result. So we're just expanding it out, getting all of the data in the file. We're saving it as a generation context type in the option enum. So this is the thing that does some or none. And the reason we do that is because the context function in the generation request that Ollama RS uses expects it to be a option enum. So that's why we just need to wrap it in option. And that's also why we saved it as a sum final data context as opposed to just final data. If decoded exists, so if decoded is actually a sum as opposed to none, that means that we know that the value exists and we can then add it to our request context. So to do that, we just call request.context and give it the context that we just decoded. Whatever was decoded then got placed into this block scoped variable context. So we're just going to be using that right here. And like I mentioned earlier, you could have called this anything. You could call this context2. You just have to type context2 here to use it. Request contains our model, the user's prompt, and it contains the context from the last chat we had. Doing all this, we can then run through the same stuff we ran through earlier, and we'll be able to get a response that uses our previously stored context. So let's just go through this again one last time. First, we're going to get all the command line arguments so that we can build the model in the prompt and optionally see if it's a reply to something. And then we're going to create a request object using our model and prompt. We're going to check to see if we have to provide an additional context. So we want to see if a user is replying to what the large language model last said. If so, let's grab that last context and let's put it into the request object. Then we're going to initialize our Ollama client and we're going to generate the request and we're going to await it. If the response was a success, print out the response, and then we're going to just write the new context into our temp file, and that way we'll have it saved for later if they want to ask another question using the same context. So let's give it a run. We're going to do cargo run llama 2 uncensored. This is command line arg1 and command line arg2 is prompt. What's the biggest US state? So this is not a reply. This is just a single start to a chat. It's going to take a second to build it all, but it will. And just a note, once it builds, the response time to actually get the response depends on how fast your computer is. So if you have a GPU, it's going to be a lot faster than if you only had a CPU. And that's just because of how a large language model actually creates responses. It has to do a lot of complex matrix multiplication, and a GPU is much better suited for that than the CPU. But if you only have a CPU, this still works. It's just going to take a longer time to get a response. So cool. Alaska is the largest US state by area, covering over 650,000 square miles, blah, blah, blah. So let's try to see if the reply function works. So you get this response, and then you're like, 650,000 square miles? What's that in kilometers? So now, if we sent just what's that in kilometers with no context, it would have no clue how to respond. But because there is context, it's smart enough to look back and see, oh, I said 650,000. I should use that as context and return this to the user. So let's see if that works. In kilometers, it's approximately 2750 km long by 1640 km wide, 1.4 million square kilometers almost. So now we know that the context works because it was able to read what's that in kilometers and infer based on our last conversation what to turn into kilometers. So now you might be wondering, hey, how did I use hey and hey-r as opposed to typing out cargo, cargo run, including the large language model and all that stuff? How did I make this so simple? And the way I did that is I used a bash script. So firstly, what we have to do is we have to turn this file into an executable. And an executable is a file that a computer can execute even if they don't have Rust. It takes all the packages and all the code over here and turns it into something that is pretty generic so that any Linux computer without Cargo or without Rust can still make use of this program. So to do that, what you do is cargo build, and you're going to be building a release. It's going to take a second, but it'll show up in the release right over here. Let's wait for it to finish. So now you have this executable binary. It's called Hey LLM. Just going to drag it over to the main folder. And as you can see, I already have it. So it's just going to overwrite the existing one, but it's going to be the same thing. So now our folder has the source code and it has an executable binary. And just to make it clear, you can think of this executable binary as just a simpler way to do cargo run dash dash. So let's just give it a try. So we're going to do hey LLM llama 2 uncensored, and we're going to say what's up. I'm good. How are you doing today? So basically that was the same thing as doing cargo run. We're just using it on the binary instead of using cargo to do it. Now that we have this, we have the power to give this to anybody else with a Linux computer and have them be able to run it without having to install anything at all other than Ollama. So now let's look at the script that I created to set this up. We're going to check to see if the user has Ollama. If the user doesn't have Ollama, so if it's null, then what we're going to do is run the Ollama install script for them. We're going to pull in llama 2 uncensored, and then we're going to export the environment variable Ollama model and assign it to the model we just downloaded for them, llama 2 uncensored. And then we're going to write it to their bash RC. Otherwise, if Ollama is already installed, then all we have to do is instantiate an Ollama model environment variable for them. In this case, we're going to do llama 2 uncensored. But if you're running this at home, you can change it to whatever model you want. And like I mentioned earlier, you can just look at the Ollama library and any of these could be your model. Even if you run this script, you can always just go into your bash RC file and just change it over there. So if you want to use something else in the future, just go to your bash RC, change it. You don't even have to run this setup script more than once. And then we're going to copy over that Hey LLM binary, and we're going to save it in the user local bin directory. So this is just where I chose to store it, but you can store it anywhere you want. You just have to change this line. And then we're going to create a thing called an alias, which is basically just a way to create a shorthand. So what we're saying is when we type hey into the console, what we really mean is go to user local bin hey LLM and then inject in the Ollama model variable, so llama 2 uncensored. So that rather than doing something like user local been hey LLM, llama 2 uncensored, how's it going? Rather than doing all that, we can just simply do, hey, how's it going? And then we're going to write it to bash RC. So then after doing all this, you're left with 2 entries in your bash RC. Export Ollama model and then the alias. So if you ever want to use a different model, just change it right here. If you followed all those instructions and did exactly what I did, you should have a new command line application. So let's give it another try. Hey, what's a synonym for cheerful? Alright, so it gives a bunch of synonyms. Now let's see if the context works. So, hey, reply. What about antonyms? Sad, depressed, gloomy, melancholy. So now we confirmed that our alias works, looking at past context works, and now we're done. And now you're able to just simply use hey and ask any question you want to your large language model, and you don't have to worry about sending your data over to Microsoft, to OpenAI, or anybody else. You get to keep control of all your data, and you don't have to share anything that you don't want to. But like I mentioned, the cost of this is the fact that you have to have a GPU so that you can get timely responses. And the benefit of this is while the answers are simpler, it's also a lot faster than Copilot. So let's run Copilot and let's run ours. So we already got an answer. The second largest country is Russia. And this one's still typing it out. And it figured it out and it gave us more context. But if you just need a super quick answer, now you can use hey to do that. So that's it. Thanks for watching. All of the code is available on GitHub, including some documentation for how to use it. And yeah, see you next time.